So if you break down vegetation, you and I see visible energy, and vegetation, as you probably full know well, the green leaf, it's green because it reflects a little bit of green energy, but it's heavily absorptive in blue and red. In other words, those are the primary color channels where vegetation absorbs light for photosynthetic purposes. But there's a whole slew of wavelengths beyond the visible where vegetation reflects really heavily because of internal leaf structure and moisture conditions, and very importantly, specific little absorption features. Those are almost like a signature that you can attribute to nitrogen or phosphorus or potassium or whichever micro or macronutrient you're talking about. You often find these signatures or absorption features beyond the visible range. So if we sample, say, from the blue through the near infrared, through even what's called the shortwave infrared region, we can actually determine which signatures or absorption features are tied to which nutrient levels. And thereby, if we, for instance, find that, I'm just using a silly example, but if we find that 950 nanometers, which is beyond what you and I can see, is tied to nitrogen absorption or nitrogen content, we can now design a sensor that senses that specific wavelength or range of wavelengths to detect that absorption feature on a routine basis for nitrogen mapping.